Hey guys, Stephen here. In this video, we're going to be covering one of two topics dealing with algebra. This one is going to be covering basic algebra, or what they call basic algebra, which accounts for 30% of the math GED. It's the biggest section out of all four topics. Jake has a square garden that measures 12 feet by 12 feet. He wants to increase the area by 25% and plans to increase the dimensions by equal lengths. Which of the following equations could be used to determine x? First, let's figure out what the area of the original garden is. Now, if it's a square garden, then to calculate area of a square or a four-sided shape, generally speaking, we want to multiply the two dimensions or the two numbers that form a 90-degree angle with each other. Since a square has all equal sides, that would essentially be 12 times 12, 144. Now, what if he wants to increase the area by 25%? Figure out what 25% of 144 is, and then add that to 144. Let's go ahead and do that method. So I'm going to leave 144 in there and times it by 25% in its decimal form, 0.25, and I get 36. I'm going to take that 36 and I'm going to add it to 144, which was originally there, and I get a 180. So that means that the new area should be 180 square feet. It looks like that kind of matches to either C or D. So now what I want to do is try to get a more accurate model of where this 180 came from as an area. So I've redrawn my square a little bit bigger with 180 on the inside representing the area or space occupied there. What we do know is that each length has 12 feet involved, but we're also adding some unknown value, which they're calling x. It says we want to increase the dimensions by equal lengths, comma, x. So in algebra language, I would express that like this: 12 plus x, 12 plus x. Just like we did 12 times 12 to get 144, we need to take both of those lengths, which are both 12 plus x, and times them by each other. And what it would look like would be this: 12 plus x, and the whole group is being squared. That would make the letter C our final answer here. 12 plus x, the whole group squared, equals 180 degrees. A passing score on a test is anything above 65. Which of the following inequalities represents all of the passing scores? So these symbols, called inequality symbols, are very common in this grouping of questions called basic algebra. Sometimes you might see them in basic math too, using these to translate certain phrases. Like the one here is less than, here's greater than. And then if we see that symbol with a line underneath it, it means less than or equal to, greater than or equal to. If they said like at least 65, then yeah, you could equal a 65 or better. But here they're saying strictly above 65. So our score has to be above or greater than 65. And then they're also using the letter S here to represent the score. So it'd be S is greater than 65, or answer choice B. All right, this is my favorite kind of math question. The one-word questions, Okay, so on the screen here are the two steps for what they mean when they say simplify in math. A good word by comparison for the word simplify is the word organize. I like to draw this comparison when it comes to simplifying with doing laundry. A basket full of laundry that needs folding. So the first step is to break open the parentheses. We need to get all of these individual pieces out of the parentheses. So that would be like taking a basket and dumping it out onto your bed or floor or whatever. In fact, since there's two parentheses here, it's almost like you have two laundry baskets and you're dumping it all out and getting it all in one big pile. Arranging them into piles, like all your shirts over here, all your socks over here, whatever. Combining together into piles the things that match, right, with your laundry. That's pretty much exactly what you do in math with combining like terms. The challenge with that step is the process of identifying what matches and how do we match things together. So now I'm going to go into a little bit more of the math detail for how to break open the parentheses, and then after that, how to combine like terms, and then we'll be able to answer this question. Okay, so here's an example of where we're going to need to break open the parentheses and combine like terms to organize the expression that I've written on the screen. First step, break open parentheses. We're going to do 3 times 1 and 3 times this minus x. So 3 times 1, and it says minus x on the inside. So 3 times negative 1x or minus 1x, which is negative 3x. It's a little tricky there, but 3 times minus x, negative 3x. When this x is in the parentheses, it's kind of like locked in there. We can't do anything with that x until we break open the parentheses and free it. Minus 3x and the positive 6x, now those two things can combine. So that's what I mean when I say combine like terms. You want to match up groups of numbers which have the same letter in it. So negative 3 plus 6 will come out to be positive 3x. And this plain old number 3, which was there all along, comes down as well. And then that's it. You leave your answer just like that as well, which is a little bit strange. And when you're simplifying an expression, again, it's all about organization. We're taking something that is semi disorganized, like this big expression up here, and we're rewriting it in a shorter and condensed way. So that is what it means to simplify. We have two groups of parentheses in this question. You could think of the number 1 as being in front of that parentheses. And the same thing goes here. Minus 1 times those things. If we put that 1 in there, that might help guide us for how to break open the parentheses properly. Now in the first parentheses, when we do 1 times x to the second power, that's just going to be x to the second power. 1 times 10x is just 10x, and 1 times 6 is just 6. But it's in the second parentheses where we do actually negative 1. We have to include that minus sign in front of it. Negative 1 times the terms on the inside. What's going to happen when you multiply by negative 1 is that everything stays the same except the sign. It goes from being a positive term to being a negative term, or vice versa. Minus 14x minus 6. So there's our first step in this question, is to break open the parentheses. So we're going to go through and we're going to try to find our matches. But before we do that, I want to indicate how many terms there are to begin with. So x squared is a term, positive 10x is a term, plus 6 is a term, minus 9x squared is a term, minus 14x is a term, and minus 6. So we have 6 terms here. X to the second power minus 9x to the second power. The x with the squared exponent, x to the second power, that tells us that it's a match. So now we look at the numbers in front and we either add or subtract them. The x squared doesn't have any number in front of it, but guess what number we can add there? Just like we did before with the parentheses, we are allowed to add the number 1, if that's helpful for you to remember. Minus 9, and 1 minus 9 comes out to be negative 8. So that's how our answer is going to start off. Negative 8x squared. Good news is we can cross those out. We are done with those. Now we can match together 2 other terms here, I think. Yep, we got positive 10x and we've got minus 14x, negative 4. And the x stays the same, 6 and minus 6. So 6 minus 6 is just 0. So the final answer is negative 8x squared minus 4x, which is answer choice C. Can't go any further than that. That's as far as we go. What is the value of, and then we have a fraction here. We're on the top of the fraction. We have x to the third power minus 2x minus 5. The bottom of the fraction is x to the third power plus 9. And It says if x is equal to -2. All right, so fractions, if you recall, a fraction, of course, is just another way of showing division where we do the top thing divided by the bottom thing. Now here they give us the value, a value for x to plug in. And that's exactly what we're going to do. But just like in the previous questions, there happens to be something on this question that is worth pointing out that is that could be taken for granted by the test writers and in algebra language in general. In a situation where you have multiple things added or subtracted in either the top of a fraction or the bottom of the fraction, as we have here, even though they don't write it, there are always assumed to be parentheses surrounding the top and the bottom of a fraction. Every fraction is like that. You could put parentheses on the top and on the bottom of every fraction, really, and it would be appropriate to do so. We need to calculate everything on the top of the fraction, get that number. Then we need to calculate everything on the bottom of the fraction and get that number. Then at the very, very end is when we're going to divide the top and the bottom. So x to the third power is the very first thing I'm going to do, which means -2 to the third power. That would mean -2 times -2 times -2 again, -8. So -2 times, and then x is equal to -2 is equal to +4. And then we have -5. So the top of the fraction comes out to be -9. -2 to the third power once again, which was -8. And then we do -8 plus 9, which comes out to be +1. -9 divided by 1, anything divided by 1 is just itself. So that's going to equal -9. Ted and Julie took a canoeing trip and traveled 10 miles upstream against a 3-mile-per-hour current. Which expression best represents the time it took Ted and Julie to travel 10 miles? Okay, so I'm scrolling down here to the algebra section. The second to last formula, d equals rt. And what those letters stand for is that it says distance is equal to our rate multiplied by time. So I'm going to write it down. D equals r times t. They want to travel 10 miles. That is a distance. So that's going to be a letter D. Now, the rate is an interesting one. It doesn't tell us exactly how fast they're going. It does tell us that however fast they're canoeing, whatever speed they're generating from them canoeing, that speed is going against a 3-mile-per-hour current. So that means that whatever speed they're going, we have to take away 3 miles per hour from that speed. And I'm actually looking over here at the answers. It looks like they use the letter S for speed, so I'm going to do the same. So I'm going to use the letter S to represent the speed that they're going in the canoe if there was no current whatsoever, because they're actively working against it. So it's basically subtracting 3 miles per hour from whatever speed they're going. Now that is my rate number, and we multiply that by time, the other unknown thing here. We don't know how long it's going to take them. That's what it's asking us. We want for that letter T to be all by itself on the right side of this equal sign. Well, right now it's not. Right now that T is being multiplied by a group, which is S minus 3 as a group. The S minus 3 group is being multiplied, or is multiplying to T. So when we move it from where it is to the other side of the equal sign, it switches from being a multiplication to being a division. So we take 10 and we're going to divide that by the group S minus 3. And when we're moving things around in an equation, when you move it to the other side, you always put it at the end. So it comes after the 10. That's important. So 10 divided by S minus 3 as a fraction would look like this. 10 over S minus 3. Answer choice D. Evaluate 2 times x squared minus 2 all over 3 times y if x equals 5 and y equals 4. Evaluate is another word for solve. So in this question, we're actually going to get an answer, and you can see that in our multiple choice selections there. 5 to the second power is 25, And 2 times that is 50. Now, if y is equal to 4, then 3 times 4 is 12. So that's the bottom of the fraction. And we're going to end up with 48 over 12, or 48 divided by 12, which is equal to 4. Expand the expression using the distributive property. I kind of get a kick out of how they write these instructions. Here, they're being extraordinarily descriptive about what they want us to do. And in like I think it was the second question we saw, they basically said all of this stuff. They used the word simplify, So in one of the questions, they used just a single word, simplify, which actually means more than this. And then here, they want us to do less, but they actually describe it, whatever. So -6 times 2 over 3x. Let's review multiplying with fractions, because ultimately we're going to do -6 times 2/3, and then the x comes along for the ride. All right, so -6 times 2 over 3. And I'm going to use a dot to represent multiplication rather than a symbol that looks like the letter x. And when you're multiplying fractions, what we need to do as a setup phase, we need to make sure that all the things are fractions, or they look like fractions, where there's exactly one number on the top and one number on the bottom. So 2/3 is fine. It's good to go. But -6, we got to do something with that to make it look like a fraction as part of our setup. And we can turn any whole number like -6 into a fraction by putting it over 1, because essentially that means -6 divided by 1, which is equal to -6. So we haven't changed the value of it. We just changed how it looks, really. But by doing that, it can help you to remember that when multiplying fractions, you just multiply all the top numbers together, and then you multiply the bottom numbers together. 1 times 3 is 3, and -12 divided by 3 is equal to -4. And then the x, as I mentioned a moment ago, tags along for the ride. And then we have -6 times +5. So to show that, I would put -30, and we're done. Solve for x. 3x plus 6 equals 7x minus 2. There's no other letter other than x. So we have enough information here to figure out the one number that x has to equal in order for the equation to be true. So there's a couple strategies you could take to solving this question. Since it's multiple choice, we could try out different numbers like the number 1. Let me just try that out for kicks. I don't know if that was going to work, but what happens if x is equal to 1? Well, if x was equal to 1, 3 times 1 would be 3, and then 7 times 1 would be 7, and we'd end up with 9 equals 5. Okay, well, that's not true. So C is not the correct answer, but you can see what I mean. Okie doke, so a couple observations before we start. We have 2 terms on the left of the equal sign, and we have 2 terms to the right of the equal sign. In this equation, we have a term with the letter x in it on both sides of the equal sign. There's one on the left of the equal sign and one on the right. When that's the case, first step is to get all of our x's together on one side of the equal sign. It doesn't matter which side, just so as it's on one. And I typically look for whatever the smaller number is of the two. But I would take the 3x and I would move that one over to the other side, basically turning it from being a plus 3x to being minus 3x. By moving the smaller term over, we're guaranteeing that we're not going to end up with negative numbers. We can now combine 7x minus 3x, 4x. We still have the minus 2 over there, and we have the positive 6 on the left of the equal sign. Next, we're going to move this minus 2 over, and it's going to become a plus 2. So 6 plus 2 is 8. That 4, which is being multiplied to the x, and move it over to the other side, making it a division. So doing like 8 divided by 4, which is 2. Drag and drop the numbers and symbols to create a rational expression. And then they give us 2 fractions there, where the 2 fractions are being multiplied to each other. 1 box on the top, 3 boxes on the bottom. Looks like we can drag and drop, okay. A rational number is any number that can be written as a fraction. We don't need to get too concerned about that. It's more technical sounding than it needs to be. I will rewrite it like this. 8x, x plus 1, on the top of the fraction. And I'm going to rearrange. I'm going to put 2x first and x squared minus 1 here. But rather than actually do the multiplication, I'm just showing that the things are being multiplied. Since this x right here is part of a multiplication question, it's not being added or subtracted, it's multiplied to its neighbors, we can cancel that out. That goes away. Also, you could think of 8 as the number 2 times 4. 8 is the same thing as 2 times 4, which by doing that, we end up with this 2 on the top and 2 on the bottom. We're a little bit closer to maybe having something that matches the drop zone here of what I could put as an answer. And we actually end up needing to do more cancellation. But we're not allowed to cancel, say, this x with this x because both of those x's are locked in the parentheses. So we cannot cancel anything with that. Instead, we're going to have to pull out this strange skill in algebra called factoring. Factoring is like working backwards in time, as silly as that sounds, to what something may have looked like before you multiplied it. So if I was to multiply, for example, 4 times x and 4 times 1, it would look like this, 4x plus 4. But also, I could take that as a starting point and factor it, meaning I could rewrite it looking as it would before I multiplied it in the first place. So factoring is kind of like undoing simplifying. Unfortunately, to solve this question, I'm going to have to use an even stranger version of factoring. It's very hard to visualize what this would have looked like before it was multiplied out. So and it has to do with what's on the bottom. So this group here on the bottom, x squared minus 1, itself can be factored in a very specific way. Both terms are perfect squares. We can take the square root of those terms and have it be a whole number answer. So when you have two things that are perfect squares that are being subtracted into parentheses, then you're allowed to factor it in the following way. It's going to be two parentheses, and the first parentheses is going to be x minus 1, and the second parentheses, you could write it as x plus 1. Kind of crazy, I know, but if I was to multiply everything back out, it would involve doing this. I would do x times x, which is x squared, x times 1, which is x, negative 1 times x, which is minus 1x, and negative 1 times 1, which is negative 1. That would result in x squared minus 1. So that's how it would look if you were to go back. Now on the top of the fraction, we still have 4, but we also have x plus 1. And now maybe you can see the final step. As a group, it is being multiplied on the top by 4, and on the bottom by x minus 1. So x plus 1 as a group shows up on the top and on the bottom of the fraction as part of a multiplication. So we can actually cancel out x plus 1 on the top and on the bottom, leaving us with 4 on the top and x minus 1 on the bottom. X minus 1. That was the most difficult question we've seen in this question set. And sometimes that'll happen in this category called basic algebra. Sometimes out of the blue, they throw in these very specialized questions. I would call this one of them because being able to factor that number, the difference of squares on the bottom, is a very, very, very specific skill. Yeah, right here, they did x squared minus 1. They factored it. It says factor the numerator and the denominator of each fraction. So they basically said that is equal to that. You could spend a week practicing that skill, and it might show up in one question out of your 46. So don't get too concerned about it. If you want to learn more about factoring like that, I would be more than happy to share. Trey has $36 in his wallet to buy gasoline. If gas costs $2.25 a gallon, which of the following represents the number of gallons, G, of gasoline that Trey can buy? If gas is $2.25 a gallon and he has $36 total to work with, we can divide our total 36 by 2.25 a gallon to get 16. So 16 is the maximum number of gallons that he could buy. Anything more than that is going to cost more than $36. So I will write that down just like I said it. It's a maximum of 16 gallons. So now we need to identify which of these four symbols is appropriate for the word maximum. Are you allowed to hit 16 gallons perfectly? Yeah. Are you allowed to go over 16 gallons? No. So we can stay under 16 gallons, less than, and we can also equal 16 gallons perfectly. So the symbol we're going to use is going to look like this: less than or equal to 16. And then they're using the letter G to represent how many gallons of gas you can buy. So this answer is A. I just wanted to say thank you. I hope this was helpful for you, and feel free to reach out if you have any questions, and I'll see you in the next video. Thanks.